video on secure code focusing on integer promotion. Identifying software vulnerabilities at the source code level is the primary object of secure code. Let's see how integer promotion helps us. Many type conversion security problems stem from the conversion of signed to unsigned types. When a signed variable is changed to an unsigned variable of the same size, the value changes correspondingly, while the bit patterns remain unchanged. When length values are represented by a signed integer and the programmer fails to account for possibility of a value smaller than 0. In this instance, when an input value is less than 0, it becomes a high positive integer, and when we converted it to an unsigned integer type. Though a variety of program interfaces, malicious users can frequently specify negative integer and compromise the logic of an application. This kind of bugs frequently occurs when an integer supplied by a user is subject to a maximum length check without first being checked to see if it is negative. So when value or expression of an integer type is used in an expression and its integer conversion rank is less than the rank of both signed and unsigned int, it is promoted to either a type signed or unsigned int. Signed int is promoted type for signed integer types and unsigned int is promoted type for unsigned integer. So what's motivation behind integer promotion? It majorly occurs for three main reasons. Operation like sign and unsign int can be carried out in a natural size for an architecture. When processors are carried out within an architecture's inherent scale, they are more efficient, like sign and unsign int. Arithmetic errors brought on by the overflow of intermediate values are avoided by integer promotions. So let's understand the concept by this small piece of code where we have a three variable declared with sign character d1 100, d2 3 and d3 is 4, and sign character output variable has this arithmetic operation d1 into d2 divided by d3, and expected output is 75 because of integer promotion. So types of d1, d2 and d3 first get promoted to sign int. The expression d1 into d2 divided by d3 is calculated and then truncated into output 75 as expected. So what if there isn't integer promotion taken place at first? What is the output? So d1 multiplied by d2, like 100 into 3 is 300. Here 10 bits are needed to represent the complement of 2. The value 44 is obtained by truncating it such that it falls inside the range that the sign character type can represent. Then if we divide by d3, the outcome is 11. Now let's understand this small piece of code where I is an unsigned integer. It's getting compared to a signed value, that is -1 in the for loop. In the condition where j is greater than -1, we are checking. Since both the type doesn't match, the signed int, that is -1, is promoted to an unsigned int value. The unsigned equivalent of -1 is his value, so the condition becomes false and control comes out of loop immediately and nothing gets printed. So behavior is undefined. Let's see the second example where I have the unsigned char variable initialized to 0, and then it's getting compared to a variable less than or equal to 255, and then I'm printing it and then incrementing it. So we have to understand the size of unsigned char in C, that is 0 to 255. And what if the value is out of range, either too large or negative? Then it is reduced by modulo to raise to power n, where n is the number of bits in the target type. So if the char has 8 bits, the value is reduced to modulo 256. So that 256 is huge numbers and it becomes 0 and we get never ending loop. So lesson learned so far is signed integer flow causes undefined behavior, whereas unsigned integer overflow causes the number to be reduced model to a power of 2. That's all for now. Thank you.